Continuing our discussion on gases, we're going to talk about Boyle's law. Boyle's law is a relationship between the pressure and the volume in the gases, or in a sample of gas, and this is going to be the same sample of gas. If you look at the picture here, I've got an experimental setup where I have a sample of gas and I have a piston. This is a closed vessel. Initially my volume is 4 liters and my pressure is 1 atmosphere. Now remember that this pressure is related to the, and I should say related to, proportional to the number of collisions on the walls of the container. Okay, now we're going to be changing the volume, decreasing the volume from 4 liters to 2 liters. One thing you need to remember in this law, okay, is the temperature of the sample remains constant. So that means my kinetic energy constant, and since it's the same gas, my velocity of the particles, that says velocity, V-E-L-I-C-O-T-Y, constant. Okay, so these particles moving at the same speed. If I decrease the volume, hopefully you can see that if the speed of these particles is the same, that's going to increase the number of collisions of those particles. So as I increase the, as I decrease the volume, the pressure is going to increase. I always think of it this way because I can envision making the volume smaller. The collisions against the walls are going to increase, therefore the pressure increases. This is known as an inverse relationship. Okay. And mathematically, we can express that as PV, pressure times volume for a system, is equal to K, a constant. This just represents a constant. Two important things to note: temperature and N being really related to number of particles. In reality is something called moles. Okay. Those do not change for the sample. So hopefully you can see pressure times volume is equal to a constant. Using that relationship and doing some math. Ooh, sorry about that. Boyle's law is typically stated like this. Okay. Again, remembering the temperature and the number of particles of the gas, the sample of the gas remains the same. How do we make that a straight line? Since this is called V being inversely proportional to P, meaning as V goes up, P goes down, that's a inversely proportional relationship. If I take this pressure and I mathematically make it the inverse pressure, just 1 over, then when I plot that, I will get a straight line. So a graph of V versus P will not be a straight line, but V versus the inverse of the pressure will be. What are we going to be doing with the Boyle's law? Well, here is a problem. Why don't you pause the screencast, see if you can set up Boyle's law, and solve for the pressure. Alright, well, if we remember that Boyle's law is P1 times V1 is equal to P2 times V2. It's always helpful for me in a problem to write out my given. What do I know? Well, I know that helium in this cylinder has a volume of 120 milliliters and a pressure of 850 milliliters. Well, those two things go together, so volume 1 is equal to 120 milliliters, pressure 1 equal to 850 millimeters mercury. Then it says new volume. What is the new volume if the pressure is changed to 425 millimeters mercury? So I don't know what V2 is, that's what I'm looking for, but P2 is 425 millimeters mercury. Remembering Boyle's law, P1 V1 equal P2 V2. I'm solving for this. Solve for that, I divide both sides by P2. So I'm going to have V2 is equal to, alright, so then that means that P2 cancels, so I'm left with V2 by itself, and I get V2 is equal to P1 V1 over P2. Substituting in, P1 is that 850 millimeters mercury times the first volume, 120 milliliters, over P2, 425 millimeters mercury. Get out your calculator. You put in 850 times 120 divided by 425, and we get 240. These units cancel out, left with milliliters. Now, taking a moment to look, what happened to my pressure over here? I decreased my pressure by about a half. Remember, if I decrease pressure, volume should increase. If it decreases by a half, my volume should about double. And oh look, my volume did double, so I'm okay on my double check.